Hi, do you want to start now? Okay, let me share the screen. Give me a minute, please, and then we can go ahead. I think it's a good moment to do it. Well, today we have a not too long presentation, okay? So we can finish on time at 9:05. That's well, the same time we are doing this. So let's go ahead. Thanks for being on time. For you, you five are doing a good job. Let me share. Please let me know. Can you watch my screen?
Yes, we can.
Okay, a green one, right?
Yes.
Perfect. Well, this presentation, as I was telling you, is not too long. Again, it's theoretical. And well, for catching some vocabulary and taking account that it's going to be useful in order to practice, to get used to this new vocabulary, and of course, studying and checking. And well, today we are going to talk about research studies, and data presentation. Okay. This information, as I was telling you, is very useful. And well, during our complete career, our complete moment, we have the opportunity to do this. Okay? So let's go ahead. Let's start with some minutes, okay? Research. Research is a systematic investigation into and study of materials and sources in order to establish facts and reach new conclusions. Of course, we all make research since we are babies. We have the opportunity to learn making research, making some experiments. Well, and it's important to consider that in order we make research, we have the opportunity to learn more and more, and of course get used to all of this new world. And well, as we establish some facts and get new conclusions, we can understand how we can go ahead, we can go through the career and get new treatments, new medication, right? Specifically, research in medicine and health disciplines conducted using scientific methods with the aim of acquiring new knowledge about health and disease. We know this. We have researchers in medicine. We as doctors during the career, during the consultation, all the activities we make, we have the opportunity to do this. We have the opportunity to take data, to help in statistics, and then help in research. About research studies specifically, a scientific study of nature that sometimes includes processes involved in health and disease. For example, clinical trials are research studies that involve people. We all know about it. One of the most common and popular ways of making research, medical research, is while trying vaccines. We all know about it. We have that group of people where research is being developed with the group A, the ones that are receiving the vaccine, the group B, the rest of the people that is receiving, I don't know, another medication maybe, the group C that is receiving nothing. Of course, they don't know that they are not receiving nothing, and we can compare the results and compare the effects. These studies may be related to new ways to screen, prevent, diagnose, and treat disease. We all know about it. One of the best examples about research is, of course, COVID-19. And actually, we had lots of papers, of documents, of articles showing the result of research, okay? About the case control studies, we have to take into account this definition. This is a study that compares two groups of people. As I was telling you, the group A and the group B. Those with a disease or condition under study, the cases, and a very similar group of people who don't have the disease or condition, the controls. How we make the control? Following the risk factors, and that's all. In this slide, we have this picture. It's from a book, and it says that in a case control study, a group of people suffering from a disease, the cases, is compared with a group of people who don't have the disease. We all know about it. For example, diabetics and no diabetics, but are similar in other ways, the controls, similar in risk factors. The two groups, the participants in the study, are compared to see if they were exposed to a possible risk factor or not. A risk factor is something which may contribute to cause the disease. This type of study is often used as a first step in identifying the cause of disease. So taking into account this definition, we have the idea what we are talking about the case control study. Very common in medicine, we all know about it. Very common in cancer, very common with chronic diseases like diabetes, hypertension, with some articular diseases like arthritis rheumatoidea, and well, lots of situations. This slide we have just for showing how it's done. We have the exposed, then exposed, that are coming from the cases. We have the controls again, exposed and exposed in past, how they were, and now how we are working on, considering the two groups. Again, with the case control studies, we can consider the smokers in order to see which ones develop lung cancer and why not the other ones. And then we can find some important and interesting conclusions, of course. About the cohort studies, we must take into account this. A research study that compares a particular outcome, such as lung cancer, in groups of individuals who are alike in many ways but differ by certain characteristics. For example, female nurses who smoke compared with female nurses who don't smoke. And we have this chart again. We have to consider this because in black and words, we have the specific vocabulary to take in count. That's why our blue guy is again here. A cohort study, a group or a cohort of people, the subjects, who are similar in the study over a period of years, period of years, of course, a longitudinal study, a period, a few years like a line, to determine if there is a relationship between exposure to a risk factor and development of the disease. We all know this. If through the time we have the risk factor and we can develop the disease. At the beginning of a prospective study, none of the subjects has the disease. All of them were sane without any condition. They are followed up of a number of years. At the end of the period, those who have developed the disease are compared with those who have not. As I was telling you, taking the lung cancer as an example, we take in count through the years how they live, the risk factors they have or they develop through the time, and then we can consider how and why they got the disease. On the other hand, we have a retrospective study. The researchers look back. We go to the past. We study the life of the patients with the groups, with the subjects, I mean, and then we can take conclusions. By studying hospital records, for example, the clinical records, or another kind of documentation that is showing us how they were in past, at what has happened in the past, comparing subjects who have developed the disease with those who have not. It could be a little harder because we have the opportunity, I mean, to lose some information or not have recorded all of the events that the subjects are suffering. That's why a retrospective study has to be so clear in order to take the data and then can make the correct control. I'm sorry. In a cohort study and in a case control study, the subjects are only observed and there is no intervention. We cannot change anything. We cannot make any treatment. We cannot do anything with our subjects. We cannot bring medications. We cannot give treatment or surgery in order to avoid or to change the risk factors, the variables that we are taking in account in order to show this. So we have to take it in account. We just look at the subjects. We just consider the situation that we are looking for. We are preparing the information, and then that's enough. With the information we collect, we make our report, our article, we complete our research, and that's all. A cohort study is more reliable method of identifying the cause of disease than a case control study, of course. But for proof of cause, a trial is needed. We need to make trials in order to develop this kind of situation. In a cohort study, as I was telling you, we get the exposure, we have the two groups of control, and then we can watch which ones develop the lung cancer. That's important to take it in account. About the trials, of course, we have to take in account the definition. We're getting this information organized. A type of research study that tests how well medical approaches work in people. So you can see, these studies test new methods of screening, prevention, diagnosis, or treatment of a disease. When we make trials, we prove how we are taking in account the information, how the patients are developing, are receiving, and are reacting to the drugs, I mean, or the medication, or vaccines, or everything we consider important. trials are one of the most important parts during our career. That's why we must take them in count. And we all know, have read at least one article or one paper when we got trials. We have controversial trials, for example, antibiotics trials or vaccine trials. They have a long period for being developed, and then we must take them in count, of course. Again, going to the book, to the text, consider the blocking words to take in count the new vocabulary, and let's read this. In a trial, a group of people who are suffering from a disease are given a particular treatment. We know about it. We have to determine the effectiveness of the treatment. In that case, a control trial is performed. We checked how the medication, how the treatment is going on. Two groups are studied. One group, the study group, is given the treatment, and the other, the control group, is not. It sounds cruel, but it's real. We have to make this, we have to take it in count. And we have to know that it's happening since medication is being developed. The controls may be given a placebo, something which seems to be identical to the treatment, but which has no effect. Okay, for example, according to vaccines, I mean, the group A receives the vaccine, group B receives the placebo. In appearance, when we look both of them, they are the same in color, in quantity, the way that it's been applied, but we know that the group is not receiving the placebo. Maybe it can be incontagious, and then we can check how the disease is being developed. In contrast to the one that are receiving the vaccine, in that way, we can see in the first hand how this disease, this situation is starting, how it's developing, and the primary effects. If there is an equal possibility that patients may be selected for the study group for the controls, the trial is said to be randomized. A randomized control trial makes bias, error in a causes which influences the result. These biases are very important to consider. Make bias to less likely. An additional way of removing bias is blinding. Patients don't know if they are receiving treatment or the placebo. Of course, patients don't have to know it, because if they know that they are receiving the placebo, all the research is going to be lost. Nobody wants to be in the group B receiving the placebo, the no treatment medication. Or maybe the ones that don't want to be there can make susceptible the ones that are receiving the new medication, and it becomes a mess. It's not possible to do. If, in addition, the researchers do not know who is receiving the treatment, the trial is a double-blind trial. So we can see we have the possibility as a researchers to be just blinding for patients, or the double-blind trial, when the developers, the scientists that are making the new vaccine, for example, know which doctor is administering the new drug to the patient, and nobody knows about it except the researcher. Randomized control trials are used to test treatments or preventive measures. We know about it. Again, we have our joke. So just for having fun and considering that it's true, all the time we are in trials, all the time, well, we have topics. We have some topics to follow until 2030. And one of the topics we have is to find 10 new antibiotics that are effective against the superbacteria, the escape bacteria. And this is an example. Well, of course, he's still in clinical trials, but looks very promising. We have promising medication at this moment, but trials, of course, are not for a month, for a semester, for a year just. They need around 10 years to be studied in a complete way and then get the correct definition. Let's go to another definition, the variable. The variables are, well, is that which is inconstant, which can or does change as contrasted with a constant. Deviation from the type in structure, form, physiology, or behavior, everything that we decide to study and can change in our patients can be measured in the group of patients in the subjects is a variable. We have to take into account this because we make research taking into account variables. Without having variables, we cannot make all of the rest of the job, right? If the subjects in the study are all aged 50, then age is a constant in the study. Age is not going to change. All of the group has to be in 50 to be in the research. That's why it's a constant variable. If their ages range from 20 to 70, the age is a variable. So we can get subjects with 25, with 35, with 40, with 50, I don't know. And that's the possibility when the subjects can vary and we get the variable done in that order. A confounding variable is any variable which is associated with both the disease and the risk factor being studied. So you have to take it in account. When we study diseases, it depends too much in how the body reacts to the situation. In that order, variables can be constant or non-constant. So it's the way we use this to understand. If such variables exist, there is no way for the researcher to know whether the difference in the risk factor or the confounding variable is the one that is truly causing the disease. So we have to take into account when we decide the limits of our study, we have to take into account the variables in order to get the best result. As we get the best result, we can go ahead and don't miss information, don't make don't make a mistake while taking the information. That mistake is very common in order to get in confusion, I mean. So taking this information, we can take in account, we can understand that variables can be independent, dependent, or controlled. Independent, the one thing you change, limit to only one in an experiment. For example, the kind of water or soda you are applying to this experiment. Independence, because you as a researcher, you choose it. A dependent is the one when the change that happens because of the independent variable. For example, the height of the health of the patient, for example. Depending on the liquid you give, how the plant is growing up, for example. A controlled variable is everything you want to remain constant and unchanging. For example, when you decide to use just water, and not changing the water, you can measure how the plant is going on. It's abstract, I know. It's not very clear how to make it. And the independent, dependent, and controlled variables are studied in order to control the information bias. So that's why it's important to take it in account. Going ahead. About the data presentation, of course, we have the experience to read with these charts. We all know about it. We all know how this is done. Data presentation is defined as the process of using various graphical formats to visually represent the relationship between two or more data sets, so that an informed decision can be made based on them. All of these pictures, these graphical formats are done in order to understand better the paragraph or the research we are making, in order to organize in a graphical way, in a visual way, the information and make it easier how it's been written. For example, when we refer to a table or a figure, we have to take in account some elements. For example, first of all, if it's a table or a figure, the number of this into the research and the title. The title, of course, is giving us the detail what it's talking about. We have the variables. We have the information organized by variables. And in the order we receive this. You can see from the newest to the oldest to get it organized. And then we can read and compare the information without making mistakes. And at the end, at the bottom, we have the fonts. We have where it's done, the bibliography could be set. And if we have some abbreviations like this, we are in the obligation to give us the key, the way of reading this, for not mixing the meaning and not losing the information. And of course, in order to understand all of the documentation that is here shown. In an article, you can write, for example, figure 1, table 1, shows, and then we give the information. Another way to express this, the information is shown in figure 1, table 1, depending on the situation, right? A good expression to use in a presentation, you can say, as you can see in table 1, as you can see in figure 1, and that's a good way to introduce the information of that kind of research we are reading to the auditorium or to our students, I don't know. But it's important to use correct expressions. As you can see, is one of the most common and useful of doing this. When we compare variables, we have to refer to a table. And we will often need to compare a variable with another. We have this example. X was twice as effective as Y. So you can see we have these expressions twice. For another one, X was 3 times as common as Y. X was twice as common as Y. So you can see we can use this these time connectors in order to make it interesting, in order to show the frequency of the variable, the frequency of the event could be. And we have these expressions, very common words, effective and common, in order to compare. And of course, the grammar rule, when we start with as, we get the new connector, and then we finish with as. Easy to make, it's social English. I know that all of you can do it. Or we may need to compare variables at the same times. For example, the number of X in 2000 was double that in 1990. Or the number of X in 2000 was triple or was 3 times that in 1990. So you can see we are comparing two periods of time and we are giving the number connector to show how it changed through the time. Another way to do this, to give the same information. There was a twofold increase in the number of X between 1990 and 2000. So you can see twofold increase in is the correct term, or threefold increased in. So taking in account these grammar rules, it's going to be easier to show information, to give an explanation, and of course, give the correct data documentation that is shown to understand the meaning that we are using. Another way to express this, the number of X increased twofold between 1990 and 2000. The number of X increased threefold between 1990 and 2000. So you can see the same expressions using another way to give the same information. The number of X doubled between 1990 and 2000, or the number of X tripled between 1990 and 2000. So you can see we have 1, 2, 3 ways of express the same idea with different expressions, with different words. We can give the same meaning, just practicing with this. When we talk about approximating, of course, we are in a presentation, we are giving that information, and we have to show how to, well, we have to show numbers. In Spanish, we don't have the custom to talk with that kind of numbers. We just round it in order to make it interesting and not using too much information, that information that can be not comfortable to the audience. That's why when referring to the data presented on slides, numbers are often rounded. For example, 41.3 becomes 41 or even 40 in order to make it interesting, as I was telling you. When this is done, this is common to use expressions of approximation. We have in the chart in black and words the most common expressions. For example, here, side effects were reported by about 40 patients. In the chart, we have 41.3 or 41.3. But while reading into the presentation for making it interesting and check the correct number, we just talk about the approximation. Around 40 patients, approximately 40 patients, roughly 40 patients, some 40 patients. All of them have the same meaning. All of them are approximations. And then all of them can help us to talk in a correct way without being bored, without being, we had 41.3 patients. Now, of course, it's not interesting. When we round it, the audience has to read the slide and get and catch the correct number, and you get it interesting, and it's easy to play with that. Numbers are frequently presented as fractions or percentages. We have this experience during our career to read this, even when the exact number is given. For example, we can say, roughly 2/3 of patients reported side effects. We have a fraction here. In percentage, 55 or some 2/3 of patients reported side effects. We are not given the exact number, but we are referring, we are talking, we are making an interesting speech, I mean, and then we can use these expressions for make it better, for make it easier to catch, to understand. Going ahead, when you want to emphasize a number, for example, 9 and 8%, you can say almost 10%, you are so close, nearly 10%, more than 9%, over 9%, you can see, or just under 10%. You can see very close, less, well, we can say more than or over, or just under, when the number is so close to this. That's why it's easier to talk in that way, to make it interesting, not being so flat while talking. And when you want to make the number seem small, you say less than 10%. Less than, I don't know, 40%. You have the idea about it, and we have in black and words the expressions we have to practice and use in order to write down about it. Going ahead, when we talk about line graphs, we all have this reading and taken during the med school books, the research, and we have the idea about it. A line graph, also known as a line chart or a line plot, is commonly drawn to show information that changes over time. We have the number of everything, for example, number of boxes of cookie sales, and the period, the days that were being on sale. You can plot it by using several points linked by straight lines. It compresses two axes called the x-axis and the y-axis. The x and the y, we all know from maths. So in that order, we have the opportunity with line graph to study an event through the time, taking into account the amount. Easy. And we have some ways to describe the lines, to describe the arrow that is giving us the information. For example, notice the verbs used to describe changes over a period of time. Very important to that kind of verbs, because we got the opportunity and then we consider these verbs when we talk about it. For example, if the arrow goes up, rise, increase, or go up. If it goes down, fall, drop, decrease, go down. In this shape, the arrow shape, reach a peak. This is the peak. Through the time, it reached the peak and then started going down. Or maybe remain the same without changes through time. Notice the difference. Rise sharply. This arrow is not the same. You can see it's through the time. It's just for a period of time, a specific moment. Rise sharply, steply, rapidly. Rise sharply, rise steply, rise rapidly. Rise steadily, rise gradually. If you write down all of them together, you can see sharply in a period of time and steadily, taking more time than usual, I mean. So those verbs are going to be so useful when you describe that kind of information. Moreover, we have the pie charts. Pie charts are very common, usually colorful, and inside can show us some percentages or some information to understand this. The pie charts are a type of graph in which a circle is divided into sectors that each represent a portion of the whole. We have slices to be done. In that way, pie charts are an effective way of showing the relationship of parts to a whole. The complete circle of or pie represents the whole, the 100%, while the parts are presented by some segments or the slices the same. And we can see here in the example the title, and we have the slices. Every slice in a color is better. Every color showing us the percentage, why it's representing, and the quantity that it's done from the total. Another way to do this, we have the slices, all of them divided in colors, and just we represent amounts, showing us the amount, the number of the study, that's all. So we have the experience to check this, to practice on this, and it's not new for you. So for reminding. In this one, we can see into the slides, into the piece, the meaning of the slice and the percentage of this. Or maybe the other one that is just with percentage and the meaning of each slice. So taking in account and making the comparison into periods of time just for taking in account. About trends and describing trends, we have some general information. A trend is the general direction in which something is developing or changing over time. We all know this. A projection is a prediction of future change. Trends and projections are usually illustrated using line graphs in which the horizontal axis represents the time. This is the time, this is how it grows up, it changes, and we have to consider this. And we have lots of vocabulary here in order to describe trends. I gave you, well, I showed you a little bit of this in the last, in previous slides, but now you have more details about it. So, in that way, verbs to describe when the line goes up, rise, jump, grow, climb, go up, increase, soar. We have more words here than in the previous slides. Verbs to describe the decline. We have fall, drop, decline, decrease, go down, plunge, plummet. All of them are synonyms in each box. Another way, when it remains the same, how to describe stay, remain, plus constant, steady, or stable. For example, stay constant, stay stable. Stay steady is rounding, so I don't advise you to use this expression. Remain constant, remain steady, remain stable. So it could be useful. And verbs to describe how. For example, it rise sharply, quickly, rapidly, steeply. We watched this in previous slides. Rise, for talking about the second one, considerably, significantly, substantially. The next one, it grows steadily, grows gradually, grows moderately. And the last one, it goes up slightly, slowly. So you can see, now we are combining the ways of talking about it. And that's for studying, for practicing. It's very important to talk in a correct way, of course. The same as in Spanish. When we talk about it, we have a word order. You have to take into account this, very important, because we cannot mix the verb and the adverb in the sentences because it's not correct. We are here for learning how to talk about it, so let's do this. The verbs is often in past tense, but always check this. Consider this. Sales fell slightly. Prices dropped sharply. Production rose steadily. So you can see all in past, and we have the meaning of this, of the adverbs following these arrows. That's why we can understand this. Checking and practicing. So don't worry, we're going to work on this tomorrow in the workshop. We have this way, this formula in grammar. There is a slight rise in sales. The same idea in another order. It's a grammar key to exchange the expression and don't sound flat. That's why I'm giving you these keys to you. There was a gradual fall in the price of, so you can see. There has been a dramatic drop in the rate of, and there will be a steady decline in the number. So you can see, you can compare this. It's another way of talking, right? About prepositions, they are in blue. They are showing us how to talk about them. We have the graph. And the graph, when we have to consider this information and describe this, we take it in count. And we say a simple description, for example, it decreased from 10 to 4. You can see the preposition from to. There was a drop of 6 units. You see, you can see. We don't say there was a drop in 6 units. Of course not. In is not the correct preposition here. It dropped by 6 units. A decrease in the number of course, we explain. Between 2010 and 2014, and then we give the explanation. From 2010 to 2014, and then we give the explanation of the detail. So you can see, using the correct preposition, we make our idea easy to take, easy to understand, and it's better to the audience or the one that is going to read the article we are describing, or maybe the class we are teaching, or for understanding, even though when we are reading, we have to identify the correct preposition and then understand this. For example, we have this other description. It started at 4 units. It peaked at 10 units. It dropped by 8 units to its lowest point at 2 units. It increased to 6 units. It remained stable between 2010 and 2012. It finished at 6 units in 2012. So you can see all the prepositions used are just describing how the line is being developed through the time, considering the units. So while practicing, we are going to catch the idea. About this, again, we have a peak noun. To reach a peak is the verb. A plateau is this line. To reach a plateau, we have the verb reach, very important to describe these trends. A fluctuation, when we get it into the verb to fluctuate, we can see. When we have this shape, a dip, the verb to dip, a noun, its lowest point or its lowest amount as a verb. To fall to its lowest point, to hit its lowest amount or point. So you can check. This way of description is useful when we give an explanation about meanings, about all the material we are describing in a graph, okay? This is just an exercise for practicing that you can make at home. It's not for evaluation, it's just for showing you that that's the way we can work on this. But of course, we have to get all the vocabulary to get this information, and it's not homework. Don't worry about this slide. I'm going to take it out when I send you. Don't worry. Now we have this bar chart. It shows the prevalence of HIV in the different countries. We have the countries, we have the millions of people, we have the percentages showing us how it's done. HIV rates have fallen in some countries as a result of safer sex, but overall trends in an increase of HIV infections. The step test increases in HIV infections occurred in Eastern Europe, Central Asia, and East Asia. But sub-Saharan Africa continued to be most affected part of the world, right? Adult infection rates in Kenya have dropped from a peak, so you can see, of 10% in the late 90s to 7% in 2003. HIV rates in pregnant women in Zimbabwe also fell over the past 2 years. Just as an information, you can see in black and words the expressions of this, and you can compare the description of the chart, and it's easy to read. And don't forget that never give up about all of this information. I know it's a lot of new vocabulary, maybe lots of new expressions, but we have the chance to do it. So that's all that it's done for tonight.
Thank you.
Is there any question about it? Any detail you want to talk now? Or maybe it could be better tomorrow during the workshop, because we have all the information there. We have exercises to practice at the moment. And of course, I'm going to send homework about it. And the last week, why I didn't send homework last week, because we didn't have too much topics to check. And we have just this theoretical class and the workshop of tomorrow. In that order, we have to take it in count, okay? So that's okay for me. I have 5. I need 3 more students, please. The ones who completed the pool can go home. That's great. And please practice the vocabulary, because tomorrow we are going to work on this. One more. Yes, thank you. Okay, anybody had a trouble watching the pool? Of course, it's your attendance. Is that okay? Everything is done. I need 1 more student. Angelica, did you fold the pool?
Yes, Doc.
Perfect. So if you want, you can leave the Zoom session. That's okay for me. And don't worry, start reading. Luis, Diana, Dr. Roger, did you fill the pool? Please let me know, because I need 1 more.
Yes, teacher, no problem. Thank you.
Okay,
Bye,
perfect.
See you tomorrow.
See you tomorrow, dears. So that's okay, that's perfect. And tomorrow, don't forget to read this, okay? To check the vocabulary again and practice all of this information. Check, because we have exercises from this.
Thank you, teacher. Good night.
Good night, Luis. Thank you so much. I'm asking by WhatsApp. Okay. Well, all of them made the pool, I think. That's all that's done. That's great for me. So that's all I was preparing to this class. I hope it's easy to understand. And well, let me ask to Dr. Condemite if he could watch the pool. Hi, Natalie. Well, he left. Okay, he couldn't. Yes, he might come to again. Hi, doctor.
Please, Iris. Can you send me the pool, please?
Yes, yes, don't worry. Let me send it to you again. I'm relaunching. Okay, can you watch this?
Yes,
Perfect.
thanks. Thanks very much. Sorry.
No, don't worry. Thanks for being
Okay,
in again.
thanks.
Okay, see you tomorrow.
Thanks, Iris.
Bye.
Okay, see you tomorrow.
Okay, it's done. Dr. Kundi might have filled it, and all the ones that were here done it.